Distinguished attendees, I extend my sincere greetings. I am going to expose this work entitled Optimal Artificial Neural Network for the Diagnosis of Chagas Disease using Approximate Entropy and Data Augmentation. Chagas disease affects 65 million people, causing 12,000 deaths annually. Untreated, it becomes a chronic condition, leading to chronic Chagasic cardiomyopathy in 20 to 40% of cases. This work focuses on addressing Chagas disease, classified as a neglected tropical disease. Its goal was to develop and optimize a deep neural network that utilizes heart rate variability quantified through approximate entropy for detection purposes. The method used an ECG database from the Central University of Venezuela, consisting of 292 patients divided into 3 groups, control with 83 healthy, CH1 composed of 102 with positive Machado Guerreiro test, and CH2, 107 with early-stage heart disease. Data preprocessing include QRS complex extraction, tachogram generation from RR intervals, noise filtering, and approximate entropy calculation for each tachogram. Append parameters were set to embedding dimension M of 2 and threshold R at 40% of the standard deviation. Missing append data were also interpolated. The densely connected neural network used 288 input nodes for append data, 3 hidden layers, 15, 10, 8 nodes, sigmoid activation, and softmax for output layer. An optimizer was used with a learning rate of 0.002, categorical cross-entropy loss, batch size of 10, and a max of 200 training epochs. The training set was 70% of subjects, the test set 30%, with 30% of the training data used for validation. Finally, scaling and jittering algorithms were selected and used to augment the number of training samples. With the proposed method, we first obtained the results shown for when we did not use data augmentation. With the confusion matrix, we calculated the parameters precision, recall, and F1 score for each group, 95% for the accuracy and 96% for the overall precision of the model were obtained, validated by the ROC curve where all AUC values are very close to 1, showing good results. On the other hand, when data augmentation was applied, the results were remarkable. The confusion matrix indicated perfect metrics with 100% accuracy and precision for the model, along with AUC values of 1, showcasing excellent classification performance. Furthermore, varying the training and test set split result in accuracy exceeding 90%, even with only 30% of the original patient data used for training. We demonstrated the power of approximate entropy in our neural network for Chagas disease diagnosis, achieving good results initially. With data augmentation, we obtained excellent classification, overcoming sample size limitations seen in previous studies, proposing in a highly reliable method using only ECG records. Finally, it is worth highlighting that a larger, non-synthetic and update database would be a good way to improve the scope of this diagnostic method and contribute to timely treatment. Thank you for your attention.